Boeing days.
Exactly.
Still asking questions about AHM. So,
exactly. No, but
John Maggiore is going to talk to you about the future for digital and sustainable aircraft maintenance environments.
Exactly. And by the way, that was a great presentation, Matt. And my favorite bullet of your presentation was everyone's leaving value on the table, and I fully agree with that. So.
Yeah, really good.
So again, I'm here from Cranfield University. You're wondering why a fellow without a British accent is from a UK university. I've been working with this university for many years, and now I'm a senior advisor for the Integrated Vehicle Health Management Center, and we'll talk a little bit more about that. And I'm going to take you on a quick journey. I am the last speaker, and by the way, I feel that's an honor to wrap up what I think is a fantastic first day of this conference. I've been to this conference many, many times. Ed, congrats. This is a great event, and it's just getting better. So thank you very much. So a little bit about Cranfield. Cranfield is a graduate school only university. It's not far from Luton. It's in an area called Milton Keynes near Luton. You're probably familiar with that. It's quite unique in that it has its own airport. It has many different applied research facilities within it. It is very focused on transportation and thus aviation and also agriculture. Also has a very fine business school. Many people, I met some people here on the floor today who got their MBAs at Cranfield. And this picture right here is the Digital Aviation Research Center. So think about this, we're at a conference. This is really a digital aviation conference. And here's a research center focused on nothing but digital aviation. So this is, I think, very relevant, and the work that they're doing at Cranfield, very relevant to this community. So we are going to talk a little bit about sustainability, and the things that we're going to go through are going to include everyone in this room realizing that sustainability is not for some other folks. We're actually supporting sustainability in this community and specifically in this MRO track. So that's what we're going to be talking about. And then we're going to talk about some very forward-looking research that's going on, which I think you'll appreciate. But I use this term digital aviation, and I like to start with just the fundamentals and start with this little cloverleaf here at the bottom. So everything in this conference really encompasses these four quadrants. And the first is somebody knows something about something. Someone has analyzed or has some knowledge and they bring it to the table, either through analysis or the data that Matt talked about, and they embody it in some software, right? So it's digital. And then they apply it in aviation. So it makes sense, digital aviation. But most importantly, it's gonna be used in someone's job, whether it's an MRO, whether it's a mechanic, whether it's a maintenance planner, which we heard about from FedEx and the efforts there, whether it's a pilot, they all have a job, and everything we're doing at this conference is about changing someone's job at that last mile. And everything that we're talking about at this conference, and again, in this community, is economic. And what we mean by that is somebody's trying to provide some efficiency, and it has to deliver enough efficiency such that someone's willing to pay for it. That's what this is about. This is about commerce. And those value props can typically be broken down into something around asset utilization. Can I use my fleet more efficiently, or can I use some asset and manage it throughout its life cycle? Can I reduce labor costs and be more efficient with my labor, especially in these times of difficulty in finding touch labor especially? Can I be more operationally excellent? Am I going to have better on-time performance? Am I going to have happier passengers? Am I going to have happier freight customers? Am I going to have delays and cancellation for which I need to pay penalties? And am I going to be efficient in my usage of fuel? And of course, the flip side of fuel is CO2 emissions. And now we start to move into the idea of sustainability. So it's interesting. When I first started working in this sustainability area, we talked about environmental, and it's kind of shifted to sustainability, and there's a reason for that. Sustainability is really a more encompassing term than just environmental. although obviously there's environmental component to it. And we've all seen through the years a lot of effort. So first of all, intrinsically, aviation innovation has been driving efficiency, more efficient aircraft, less noisy aircraft. Fuel economy has gone much, much higher since the dawn of the jet age. And by the way, noise, have any of you been around a 707 recently? I have. They fly out of Boeing Field for the AWACS. It's shockingly loud. And you can't believe that when some of us were children, that's how all aircraft were. It's amazing. And of course, you know, some of the things, I'm going to touch on a couple of these. So you see the winglet. Obviously, you don't hardly see a modern aircraft without a winglet. But at one time, we were retrofitting these winglets, of course, to change the lift and drag ratio to be more efficient. And a lot of investment over the years to try to bridge the operational aspects with the machine. And that picture at the bottom is the Boeing Echo Demonstrator. Just had its 10-year anniversary this year. Proud to say that I was able to work with that program to demonstrate new technology. So again, in that operational realm. A big thing we hear about today, of course, is sustainable aviation fuel. And there are a couple of large pillars which support where we're going as an industry when we talk about sustainability. That's one of them. And of course, the whole notion of sustainable aviation fuel is that we're going to have a drop-in replacement for kerosene, which through its life cycle is net carbon neutral. That's great news. The bad news is only about 1/10% of fuel used today is sustainable aviation fuel. So a very early part of the journey. So there's a lot of effort going on. If you're interested in this ICAO publication that came out this year is a great inventory of what's going on. And, you know, Harvard Business School talks about the triple bottom line. This is another great example of why this is important. So the triple bottom line is profit, people, and planet. And basically, there's a great write-up on that if you look it up. But obviously, whatever we're doing has to make money. Luckily, the efficiencies which we're driving do provide valuable efficiencies and are profitable. Obviously, we want to support our people and the population of the world, but also protect our planet. So triple bottom line is a good way that encompasses what we're talking about. So I do want to talk about one specific technology, because this, I think, is, in my opinion, my personal opinion, is going to be the future. There's, you know, obviously I drive an electric vehicle. It's great. And that you can see with cars, that's taking off. At some point, we're going to move to electric propulsion. And the question is, how will it be powered? And I personally believe it'll be hydrogen. So this aircraft on the left, this is called Project Fresson. This will be the first aircraft to fly a revenue passenger flight, fully electric with zero tailpipe emissions. That's a Britten Norman. It's an Islander. And what you see there, you see those big tanks there. Those are actually high pressure gaseous hydrogen fuel. And they've replaced the engines with electric motors and hydrogen fuel cells, converters into that under the nacelle. So this is flying today. It's going to revolutionize, I think, where this is going. And there's a great video on YouTube, if you just type in Project Fresson, that talks about the engineering trades they did to do this. And I think it presages where this is heading. You hear some very smart people like Cranfield Aerospace and others talking about this. But just as we talked about sustainable aviation fuel and only 0.1% being used, so we're in its infancy, same thing with hydrogen. There is so much work to do with infrastructure. So, and it's not just enough to, you know, there's plenty of hydrogen out there. You have to have clean hydrogen that is going to make sense from a sustainability. So Cranfield is very focused, of course, on research, a lot of smart folks doing research, working with industry to figure out how to create clean hydrogen in different ways. So I would say in 10 years, this will be a whole different discussion. Now, again, we're starting on the smaller side of the equation in terms of the aircraft, but this is the future, the medium future. So I said, starting off, that this is really relevant to this room, and this is the MRO track, right? We're all in their MRO track. Now, many of you may have sat through some of the flight ops in the sustainability track, and full stop, the pilots and the flight crews and the fuel planners really do control the levers to a lot of the sustainability and certainly fuel economy. I mean, we've got airline rules which have to be applied. We have to monitor the pilot behavior. We have to understand the behavior of that aircraft. And we have to decentralize some of the authority and the control to the flight crew so they can make trades to be more efficient. And as you've probably seen, you can be up to 3 or 4% more efficient with fuel by having the right information, going back to that cloverleaf, insights applied to someone's job using analytics. And that's a picture right there of a smart EFB. So this is a big part of what we can do in digital, but it's not the only part. And I want to talk a little bit about a couple of examples in the technical operations domain. Again, I'm here representing the Integrated Vehicle Health Management Center, and it's also an area of passion and some expertise. So I'm going to give an example of a health management. So this is a valve. It's this one particular one is a high pressure shutoff valve on a wide body aircraft. And a valve, as you might imagine, has a moving part. It is very critical. Obviously, it's part of the Environmental Control Center, and there's lots of valves throughout the system. This is just picked one. But I'm going to talk about the benefits and the penalties. So if we can predict the failure of this part, well, we're going to avoid some penalties. And by the way, things with moving parts lend themselves very, very well to health management. So we can sense and understand, there's different methods we can use to understand the impending failure of a moving part like a valve. If we don't do that, we're going to experience penalties. And this particular part, and typical of its family, you can in fact fly with a failed valve, but you have to lock some things out. You're going to take some very heavy fuel performance penalties, like 4% fuel burn, which is very, very high. You would probably be limited with ETOPS, and also you have some other performance penalties. So practically, on an economic level, they're probably not going to fly with that. They might fly home, but they're probably not going to be flying a passenger flight. So because the penalty is too high. But by using analytics and some data, we can, preferably prevent that. Just my last international flight, I was actually, the flight diverted. We were going on vacation, and it diverted from northern Canada back to Minneapolis because the engine anti-ice valve failed. And I was wishing they had done that, but they didn't. So this happens today. So think about, let's kind of apply this into the world of operations and sustainability. What happens when you have a failure that was avoidable, which happens? Well, you have the action of either predicting it and addressing it in advance or not. And then you have some very direct benefits. And the flip side, of course, is penalties. So again, if you have to divert, if you have to maybe take a large delay or even cancel a flight, those all have very direct economic penalties. If you have to go reposition an aircraft, well, that's a direct sustainability benefit avoided or a penalty. And again, so you have one action with some direct sustainability benefits, with multiple economic benefits, and then each of them you've got follow-on. So again, if you avoid a delay or cancellation or air turnback, obviously you're going to have better performance. That's going to help everything, your bottom line, customer satisfaction. And if you're flying and trying to rebook passengers and doing maintenance at an out base, and perhaps even borrowing parts or shipping parts expedited across the world, there are economic benefits to avoiding that and obviously penalties of doing it. So this is a kind of a tenet I want to leave you with. Very few things are singular. Something may happen or it doesn't happen, but there's many follow-on effects. Moreover, if we open the aperture a bit and we think about the things we can do with digital, and obviously many of these you know, we can monitor in-flight data to understand the performance of the airplane. I can put the right airplane on the right route. I can optimize the air traffic at a busy airport like Heathrow, for instance. I can optimize my route during the flight and cut off parts, make the actual route more direct. And as Matt talked about the digital MRO, he was talking about all the efficiencies that they achieve. I would posit that there are many environmental or sustainability benefits of digital MRO, because I know there are. And then we can also manage the asset life cycle of our assets, fleets, et cetera. Moreover, we can do more than just save fuel and CO2. We can lower emissions. We can also prevent pollution. We can just use lower energy even at the airports, waste less material, have lower noise, and even improve biodiversity if we can grow the industry without having to create new airports. And moreover, we can use analytics to do some smart modeling to future-proof the success of all these big moves we're making. So for instance, that Project Fresson, that's what Cranfield University is doing for Cranfield Aerospace. They're using advanced modeling to make sure this is all working so you don't spend a lot of money and have it not work. So there's even another layer of ways we can help out and support this future. So I'm going to introduce a new term, the present value of sustainability. So did a little math, and in the abstract, what this is showing us in this chart, you can see, let's say we have 10 companies out here on the floor who have an offering which supports sustainability. And in the next 5 years, we double their market share between now and the next 5 years, and then it doesn't grow. And compare that to a big move, which might be 10 to 20 times higher in terms of its payback, but it starts in 10 years and ramps up over the following 10 years. Guess what? The difference of that growth has a higher present value than what's going to be happening later. So not to say we shouldn't do the things later, but the point is, we in this room, we in this community are helping today. Our success will help the industry succeed in this case. Again, keep in mind, the goal is net carbon zero emissions by 2050, and we're not on track. So one of my worries is we're doing things today, we're not taking credit for them, and I'm not sure we all understand how we play a role in that thread, if you will. So sooner is better. How's that? All right, we're going to shift gears a little bit. And this is the last couple slides of the day. So let's don't talk about the next 5, 10, even 20 years. Where is this going to be? Where are we going to be in maybe 30 years? Well, we have a lot of smart people, professors and PhD candidates working on this. And what we think this is going to look like, in terms of having more efficient aircraft, safer aircraft, and more sustainable aircraft throughout their life cycle, is what we call the conscious aircraft. You say, well, what does that mean? Well, what is consciousness? Consciousness is self-aware. I'm here and I know I am. So think about an aircraft which is self-aware, which has an enhanced human-machine interface, is using the state-of-the-art air-to-ground communication, and is also bringing in some of the tenets of neuroscience and combining them with AI, and kind of breaking down the conceptual stovepipes such that the aircraft is self-aware not only of its health of individual systems, but how it's being operated, where it is, et cetera. So think about an organism, not literally an organism, but you can see the organic drawing of that picture that is practically a conscious aircraft inspired by an organism. And that's where we think this is inevitably going. So it may not be called this in 30 years, but we think this is where it's going. And we think it's going to have a huge payback in terms of both economic efficiency and sustainability. So we've kind of been on a journey. We talked about what digital aviation is. We've talked about where, and kind of a very quick run through of sustainability, seeing that how we can, in this room, by using analytics, affect it. And then we've taken a quick look at what the future might hold. And with that, you know, I'll just go through the key points. Sooner is better. So if we're successful, the industry will be successful in this regard. But the pilots will always be a key part of this. Integrated vehicle health management and digital MRO are key, though, and probably are underappreciated, and maybe we're not appreciating ourselves enough. The benefits are beyond CO2, and we do think this idea of a conscious aircraft is going to be revolutionary. It's a little bit high concept. And when I first learned about it, I kind of tilted my head. But the more I've worked with the scientists who are working on this, I can see now that this is going to be the future. So with that, thank you very much, and I'm again thank the organizers of the conference. And any questions?
Well, thank you, John. There aren't any questions in the app. Does anyone want to make any question or comment from the floor?
Oh, yes, sir.
That's great. This is absolutely great what you're up to over there. I think it's absolutely fantastic. Not just because my grandfather flew the first B-17 at the World War thing,
Yeah.
with Doolittle, but the conscious aircraft, is that going to, would that be autonomous on kind of taxiing? Is it autonomy involved at all?
It might be. That's not the goal. I mean, that's in my opinion, and from what I've seen, it might be a parallel path. And by the way, Cranfield is an old RAF base from World War II. But yeah, and again, if you go on YouTube and type in conscious aircraft, Ian Jenyons has a great 20-minute summary of this, and it's really fascinating. And then we have some more papers on it too. So, but to me, it's somewhat. I've watched. I like science fiction, and I can see the inevitability of some of this stuff. And it may seem like science fiction now, but I think it's going to be there. Anything else?
Yeah, I can say from first-hand experience that Cranfield is an amazing place to visit. You've got autonomous pod cars rolling around one side of the airfield. There's all kinds of things going on there. My brother lives in Hatfield Avenue, so Hatfield is where the first blind landing took place in the Trident many years ago. So yeah, so it's steeped in history and a very interesting place. So,
Well said.
Really thought-provoking presentation there. So thank you, John.
Thank you. Oh, and so we
One
can.
more question over here.
I sent you the app, maybe a bit late. I saw your cost comparison to where you can save.
Oh yeah.
As somebody working on the ground instead of inside the aircraft, where do you see in a conscious aircraft a place for a crew on board an aircraft? Because in regards to cost, they're the most expensive ones.
Well, this is true. This is true. Well, I'll start with the maintenance side. I mean, one of the goals is no maintenance. There's no way we're going to get to no maintenance, but you have to have an asymptote towards that no maintenance. So that's a North Star. I don't want to talk about the flight crew because no flight crew. But I'll let you draw your own conclusions. But that's not what this is about. But I mean, we can watch where we're. Yeah. But less. I mean, efficiency is intrinsically less touch activity, more adaptability, and potentially even self-healing. Certainly in the software side and the configuration management. Yeah, it's a good question.
Yeah, my apologies for missing your question there. in the app, it's not showing me that there's a question there unless I open it several times. It doesn't give me a question, but there we are. I think we'll close the day.
Thank you.
I think you'll agree with me that